Right, this is this high-speed, excuse me, I got a bit of a frog there, boys. Right, that's better. With this is the high-speed drilling attachments I've been working on. It consists of the motor. It's got it off the internet. Banggood and eBay do them. You have to be careful which ones you buy. The smaller ones with the 3mm shaft are not really very manly. They're a bit wobbly and not very robust at all. This one's got a 5mm output shaft. It's rated at 12 to 24 volts. It'll give a speed of 4,000 revs at 12 volts and 8,000 at 24, and it delivers about 100 amp of power. It comes complete with a very nice little chuck. It's not bad quality chuck, that isn't actually. It runs nice and true. Held on with a little adapter there onto the shaft. And the motors are mounted to this flange here that I made by these two bolts here. They're 4mm. Well, one of the important critical part about it is that you have the shaft and the mandrel all in line with one another. If it's out of line, and the drill's going in like that, you're going to put a bending moment on it and break it. Hope you understand that. So unable to do that, what I did is I first roughed the cap up on the step there, fastened it to the motor. I had the drill off by that time, gripped it in the chuck there, and I had a female centre that end, and I had to put a little drive dog on the front of it here to went round, and then I skimmed this face up and that face there, so and that way that register on the cap and that face will be perfectly square and concentric to the shaft. The body part of it here consists of, in my case, because I use M3 tapers, M3 taper arbor, and this particular one has got 1/2 inch UNF thread there, and that screws into this body here, which are made from 2 1/4 diameter piece of aluminium. As you can see down there, I had to remove quite a bit of meat inside. The motor is actually 42mm diameter. And drill holes at the end so the cap and the motor could fasten to it. And I put some holes around the outside for cooling, and also around the back, and also allow entrance for the cable. When I got the Morse taper screwed on, my lathe has also got an M3 taper in the headstock, so that went into the headstock, ran it through, and then I bored. You only need to bore it a little first, sort of 10mm, so it was a nice fit on the cap there, and I also squared it off. That way, when everything's all assembled, everything then will automatically come perfectly in line. Because my milling machine on the tailstock, my lathe on the tailstock is M3, headstock is M3, and also my milling machine is M3, I can use it on my lathe, or I can use it on my milling machine. You need a transformer for it. Now I've got a transformer on order. It's a variable one. So what I should be able to do, I should be able to variable the speed on it. Well, in the meantime, what I've been using, where are we? Is this. It's the power unit off an old laptop. It delivers 17, just trying to see what volts, 18 volts. So the drill should be running at about 5,000 revs when it's coupled to that. It's a bit of a lash up, but it works. Okay, I'll put it back together and I'll demonstrate it running. Now I have had it running. I've drilled holes 1/2 mm diameter through a piece of 5-10mm brass. So it's quite successful. Bye now. Right, that's a 0.45 of a millimetre hole I've just drilled in, which is 20 thou. Hope you saw it okay. Right, I'm just going to start off with a little CNC spot drill just to give the tiny drill a start. Motor runs lovely and quiet. Right, that's all it needs. Right, this is a 0.7 drill, which is 0.28 which is 28 thou. I'm going to drill through this little snub of brass here, which is 10mm deep. Let's see how it goes. Just having to keep bringing it out and just relieve the swarf so it doesn't block up and break. You can hear the motor start to labour when it starts to cut. Right, that's it through. The motor's running at about 5,000 revs. Right, I've got the high-speed drill mounted in my milling machine now, and I'm going to try and drill a 1/2 mil hole through this piece of brass. It's about 6 or 7 mil thick. Taking it back to clear the swarf out the hole. There you go, that's it all the way through.